Rita Parsons, and I support our customers with their plant floor reliability and risk assessment projects, along with digital transformation in the Colorado and Wyoming areas. This is the second of a 5-series discussion around industrial networks. In today's session, we'll be focused on virtualization for the OT environment. We hope to make this session interactive for everyone, so please feel free to chime in by either raising your hand or using the chat feature. Please keep yourself muted when not speaking, as we'll be recording this session and posting it onto our Rexel Delivered Services YouTube channel within the next couple of days. With me today is Trevor Schutz. He's our network engineer for the region. Trevor brings expertise in terms of building and maintaining complex networks in plant and enterprise environments. He has experience in managing highly available server infrastructure in manufacturing environments to ensure continuous operation. He's helped commission multiple or many fault-tolerant and redundant servers like Stratus FT Server and ZTC Edge, and has implemented countless switches and set up various software applications for our customers. Trevor holds over 12 different certifications, one of those which is the Cisco Certified Network Associate, Cisco Certified Design Associate, several Windows Server Administrator certifications, networking fundamentals. He is our industrial network specialist, and also has some expertise in cybersecurity. So Trevor, thank you for joining us today.
Yeah, thank you for having me. All right, so like Zita said, today we'll be talking about virtualization for the OT environment. We kind of already went over our introductions, but here's a list of what else we're going to be talking about today. So what is virtualization and why it matters? What are the components used? The basics of how a virtual environment is administered, fault tolerance and high availability and what their differences are, the benefits of virtualization, and then we'll go over a little bit of a case study here at the end. So Zita, go ahead and go to the next slide. So what is virtualization? Well, in short order, virtualization is the concept of running a physical operating system or multiple physical operating systems on one piece of hardware, with each machine sharing the resources of that one physical machine. And I do use a lot of words interchangeably, a lot of terms and abbreviations. So if there's any questions about me skipping between different ones, please, like Zita said, please stick your hands up and ask questions. I'll be more than happy to clarify any further. So some of the pieces of virtualization here, we gain partitioning. So again, we can run multiple operating systems on one physical device. The resources of that physical machine are then divided between the multiple virtual machines running on it. We gain isolation. There's fault and security isolations at the hardware level. So if there's an issue with one virtual machine, operating system crashes, something like that, that doesn't affect the other virtual machines. Encapsulation. The entire state of the virtual machine is a file. So you're not having to worry about hard drive, magnetic issues with the hard drives or anything like that. It's a file that can be moved and copied from one physical machine to the other. And then hardware independence. It doesn't matter what hardware vendor you use, whether it's Dell, Cisco, HP, Stratus, the physical hardware that's running it doesn't matter. The virtual machine can, as long as the hypervisor, the part that actually runs the multiple virtual machines, as long as that is the same, your hardware can be different. Go ahead, next slide, Zita. So where does virtualization fit in a traditional architecture? Well, logically and sometimes physically, virtualization sits at the same level as the control room. Physically, though, it can be anywhere throughout the network as long as there's networking to that location. In my experience, typically I put the virtualization as far away from human interaction as possible, so that there's just no chance of somebody accidentally bumping a machine, accidentally pulling a power cord, spilling a cup of coffee on a server, things like that. Another instance where virtualization can exist is on laptops for engineers. As you know, some of the Rockwell legacy software is not supported on Windows 10, so you need to run Oops, it looks like we're not seeing the presentation. We just got to chat about that.
Yeah, let me try. Let me stop sharing and try sharing again.
Yep. So I'll get back to the engineers using virtualization. So the Windows 7 operating system isn't supported by Windows anymore. So it means it's not getting patches, right? Not getting security patches. Your systems are not staying up to date. But you may be running legacy hardware and software that requires Windows 7. So to mitigate security risk there, you can run Windows 7 in a virtual machine on an engineer's laptop so that they can still access that legacy software and still administer that legacy hardware without having as much security risk as you would be if you just ran a Windows 7 laptop or desktop to do the same function. Go ahead, Zita, next slide. So what are some of the components of virtualization? Well, on the left-hand side, we have the traditional architecture. In this instance, you would have multiple physical servers, each running their own individual operating system. On each of those servers, you would then have your applications running within that operating system. And then you have as many physical servers running as you have applications. So you'd have an HMI server, a historian, remote desktop services, things like that to meet your best practices. Because as Rockwell recommends, you shouldn't have multiple applications running on the same machine. On the right-hand side, we see what a virtual architecture looks like. In here, we have a physical server running a hypervisor operating system. Sometimes it's called, or that is called virtual host. In this instance, we're talking about the VMware infrastructure. So in this case, it's VMware vSphere is the hypervisor that's running. There are multiple options though. VMware offers some, Windows offers their Hyper-V, and then there are multiple Linux variants of hypervisors. On that hypervisor, you're running multiple virtual instances of a Windows operating system. And then within those virtual instances, also called virtual machines, you're then running your applications. So you have multiple different virtual machines running your different applications instead of different physical servers. So that cuts down on hardware costs overall. The only limiting factor for the number of virtual machines that can be run on a physical host is the resources available. So the RAM, processor, and storage space available on the physical host are the limiting factors. Go ahead, Zita, next slide. So you might think to yourself that, well, if I have all these virtual machines running on one physical server, that administration is probably a nightmare. Well, VMware makes it easy with an application that they call vCenter Server. vCenter Server allows you to manage multiple virtual hosts and virtual machines from one location. It's a web interface that you log into, and you can see all of your virtual infrastructure from that one pane of glass. You can manage things like storage, networking, and virtual machines on all the virtual hosts you have in your environment. vCenter, though, is not where you would use the virtual machines in your environment. It truly is just an administration tool to add virtual machines, to add networking to a machine, to add extra storage space to a machine, things like that. Well, high availability is where resources, on the left-hand side, resources like CPU, RAM, and storage are shared across multiple physical servers. If one physical server fails, like we see here in the middle, the virtual machines that were running on that server are shut down, migrated over to the healthy physical servers that are in that resource pool, and then restarted. In this case, there is some downtime. However long it takes for a virtual machine to restart is going to be the window of downtime that you see. And there is a potential for data loss there. If you're running Historian or something like that, the time from when the machine shuts down to when it reboots, that data will not be captured. On the right-hand side, we see fault tolerance. And there are two different types of fault tolerance, which we'll talk about both software and hardware. In either case, the virtual machines are replicated across the two different hosts running the same application at the same time. In this instance, if one host fails, from a software fault tolerance side, the user might see a slight delay while the software does its magic behind the scenes to determine, is this host really down and do I need to transfer processing? But there's no data lost because it's going to both machines at the exact same time. In a hardware fault tolerant state, there is no delay on the user side because it's an instantaneous failover from one to the other. Again, there is no data loss because both machines were processing the same thing at the same time. How you decide between those hardware highly available or fault tolerance is based on criticality. So like we talked about earlier, if you have a historian and you're in a heavily regulated industry where fines can be assessed based on lack of data, typically somewhere like that you would use fault tolerance. That way your data is always backed up, is always being captured when it's being created. Something else though that's a little less critical, like a domain controller that can handle being down for 10 or so minutes while the system reboots. Something like that can be done in a high availability state because you're not necessarily relying on the continuous uptime of a system like a domain controller. Rexel offers multiple solutions for any situation that you may come across. We utilize hardware from both Rockwell and Stratus to meet any of our customer needs. Rockwell offers a solution that they call the VersaVirtual, and it can use high availability as well as software fault tolerance with VMware. With the fault tolerance side, though, there are some restrictions that need to be taken into account when deciding on this option. The solution also comes with managed services from Rockwell that includes support, remote monitoring, and administration of the system. So that in this case, you don't have to be a virtual machine expert or virtual environment administration expert to utilize this option. Rockwell can actually come in and do the administration for you, add virtual machines, make sure systems are being patched, add storage, add resources, memory, processing power, things like that to existing virtual machines. Stratus offers multiple solutions for both high availability and fault tolerance. One solution like the ZTC Edge, they have a 100 and 110i options that are meant for 2 to 6 virtual machines, but they do both high availability and software fault tolerance. Then they also offer their larger FT server option, which is the hardware fault tolerance option. This system is designed to run an entire processing environment and can usually run up to about 20 virtual machines, depending on the size of the system. In this case, you do have to have a little more expertise, but not much, to run the system. And then Rexel can also come in and help administer that environment as well if you or your customers are not comfortable administering that type of environment. Go ahead, Zito. All right. So what are some of the benefits that we gain by using virtualization? Well, we get greater flexibility and ease of adding or expanding things like production lines or new plants. It's easier to add a virtual machine than it is to add a physical machine because in the case of virtual environment, you already have the physical server there running the systems. It's easy enough to add a new virtual machine, and even easier by using something like a virtual machine template that's pre-configured for a specific task within an environment. We gain better cost control by taking advantage of things like server consolidation, lowered licensing costs, and less overhead. Lower total cost of ownership, because here we're able to run multiple virtual machines on one piece of hardware instead of a one-to-one hardware to application ratio. One study from the Uptime Institute claims that consolidating a one rack unit server can save up to $500 in energy, about $500 in operating system licensing, and about $1,500 in hardware costs over 1 year. So by consolidating just one physical server into a virtual machine or into a virtual environment, you're saving you can save up to $2,500 a year. Backups in a virtual environment are much easier than they are on physical machines. There's software that can go in and grab the exact state of a virtual machine at any given point in time and pull those off so that they can be backed up either on site or then shipped off site for your 3-2-1 backup protocols. hardware, with the hardware, you can update legacy hardware for older operating systems. So if you run a critical piece of machinery that is running a legacy piece of software, you can actually update the hardware that's running that system, but keep the operating system. So if you have a computer that you're worried about is failing, that's running, say, Windows XP, which is very, very old, and you're probably, if you're running that, you probably have a plan to update it, but you need something in the interim. You can virtualize that physical computer and use that as a stopgap while making a transition from that legacy software on failing hardware. Go ahead, Zito. All right, so now let's get into our case study. This is a little confidential, so we can't quite give customer information, but they were a water wastewater customer that recently had a cybersecurity incident that took down their entire infrastructure. Everybody talked the challenge. Everyone talks about disaster recovery and how important it is, but most of the time there are no disaster recovery plans implemented. Usually, though, in these plans, one of the first things to be accomplished is having backups of critical infrastructure. This customer had successfully implemented these backups of their virtual environment. The outcome was they had a significantly reduced downtime event. So by having backups of their virtual environment, they were able to successfully restore critical applications relatively quickly. They were able to restore these applications onto a laptop running VMware, and were still able to operate their facility. While the facility was running on this laptop, their IT team was then able to go in and clean up the servers that had been affected by the cybersecurity incident. Once the cleanup process had been completed, they were then able to migrate the virtual machines off the laptop and back onto the servers that they had been running on. They were able to also then restore any additional applications that had not been previously running on that laptop. By having these backups of their critical infrastructure, they're able to significantly reduce that downtime window and that their process could have faced. Now this isn't a backup success story. This is a virtualization success story. Yes, with physical machines, you can do backups to some extent, but that's usually limited to configuration backups. In a virtual environment, you're able to capture the entire state of that machine, configurations, software installed, network and security settings, all at the same time, and you're able to restore the entire state in case of an emergency. Physical system backups of configurations are certainly better than nothing, but there are many more steps that are needed to take place to bring the physical system back online. You have to reinstall software, you have to reset configurations, you have to go implement security settings, things like that. And in a critical system like a water wastewater facility, those steps could have just taken too long. So with that, I know I went through it a little fast. So Zita, I will turn it back over to you, and we can go ahead and close out.
All right. So thank you for joining us today, and I look forward to seeing you at our next Tech Talk.